You know, I've never really been all that familiar with the two-stroke engine, and in times like these, most rational people would hit the books. But I, however, like to do things a little bit differently. So today, I'm going to build a two-stroke of my own. And first, I'll need some materials. Which was easy enough. Most of these are things that I was able to find at a few hardware stores around town. I think this can cut through steel. I don't know. Now, what separates the two-stroke engine from its counterpart is that instead of combustion occurring every 4 piston strokes, it occurs every other. When the piston rises up, it draws in air and fuel from the carburetor. Then, as it goes back down, the mixture gets transferred into the cylinder, which then begins the cycle. And I should mention that this is only like half the picture. I could spend ages talking about different exhaust designs, but that's a subject for a later video, as it's far more important to first start by making something that will actually work. So, I spent a few days in Onshape working on this design. And I should be able to make this whole thing not only with the materials that I have, but also with my tools that I've got available. But the only way to know for sure is to jump right in. So the first order of business is to make the crankcase. After cutting the threaded ends off the pipe, I then threw it into the lathe to turn it down to the final size. Which, might I say, is a lot of fun inside of a closed ventless garage.
Oh my god, it's up on the ceiling.
In spite of all that, I was left with this as a final product. And while it is dimensionally correct, the exterior finish is just not that good. Which isn't a big deal.
Hello!
I just threw it back in the lathe, then gave it a once-over with some sandpaper. And yeah, that looks much better. Alright, so next I need to add this flat part here, which is where the cylinder will bolt onto. Once these square bars were machined down to size, I cut them lengthways to create a flat side, then I drilled and tapped some holes. And so far it looks pretty good. Now I just need to weld the square bits onto the top of the cylinder.
Oh, it's stuck to the...
But just wait a minute, Cameron Bowen. What about this giant gap? Simple. I'm just gonna keep welding over it until I've filled it in. Now look, I've seen all of the
kind
and
supportive
things you guys have been saying about my welds. So I've spent a lot of time practicing my technique, so there is no way that I could look like a fool on the internet.
Minus all the spatter, that's not awful. That's at least gotta be worth, like, federal minimum wage.
Whatever it's worth, as long as it's better than this disaster, I'm totally cool with it. Once I was finished welding, I sanded down the top side to create a flat surface. I don't really care about the giant gaps in the middle, since next I'm going to cut a hole there with this hole saw. But then I realized I could instead just throw it in my lathe and make it do all the work. And then go to Home Depot to get my $40 back. I take that back. This is really dumb. Because the pipe kept moving around in the chuck, it ended up just cutting more of an oval shape than anything. So, back to the hole saw I go. Now, I've never actually used one of these before, but I have seen videos of other people using them, and if I can teach myself to drive by playing video games, then surely I can figure this out myself.
Thank the Lord. That was awful. Look at that. Chewed it right off. Milwaukee Bulldozer.
After adding a few extra features to the case, the only thing left to do is to make the backside.
Wow, pencil on a gray surface. Very high contrast.
Once I had the plate cut roughly into the shape of a circle, I then made this little tool which fits directly in the center. This way, I can clamp it in the lathe chuck, then slowly turn it down until it's a perfect circle. Once I had it down to the size I needed, I removed the rod, then put it back in the lathe to bore out the middle. Now I can weld a section of pipe into the hole, and this is where the bearings will later be pressed into. And this type of fitment is called an interference fit, as there's just enough interference between the bearing and the part that it will be held in by friction.
Oh wow. It's like exactly 28 millimeters. Okay, so that makes my life slightly easier.
Because the bearing measures in at exactly 28 millimeters, then that means the bore size needs to be around 27.97 millimeters to form a tight fit. Because the interference needed to be so exact, and the word precision isn't really in this thing's vocabulary, I spent around 15 minutes or so jumping back and forth between cutting and measuring, to be absolutely sure that I wouldn't go over. And as you can see, it is exactly where it needs to be. Now look, I'm no inheritance machining, but you know, that is not too shabby. In fact, you might even say that it's almost good. Anyways, after welding it together, the crankcase is completely finished. So, next I'm gonna make the cylinder. But first, I want to tell you about Onshape, the free web-based CAD software. Whether you're a hobbyist or a professional in the industry, Onshape's cloud-based architecture is a perfect solution, as I can be working on a project here and then later pick it up again from anywhere around the world. And because Onshape records every action made throughout a project's development, it makes it super easy to go back and make changes if something doesn't quite work out. Onshape also has a massive community supporting it, as not only can you search amongst a huge library of public documents, but you can also add or create your own feature scripts. For example, instead of having to meticulously create gears yourself, you can simply just add a feature script that does all the work for you. Onshape is now offering up to 6 months of the professional subscription, all for free, at onshape.pro/CamdenBowen. The link will be in the description below. After cleaning up the pipe on the lathe, next I went on to cut all the ports.
Yeah, you can barely see that.
And for the most part, it was going pretty well. But just as I was cutting the exhaust port, I managed to put it in the completely wrong spot. Now I was thinking of starting over, but it's also like 2 AM, and I really don't want to do all that again. So, I'm gonna try something else. I used my welder to slowly build up material inside the port. And after cleaning it up on the lathe, I could then cut the port again in the right spot. So, now that that's out of the way, I then went on to make all the other pieces I needed. The small stuff like the intake and exhaust port wasn't very difficult, as it just required a lot of cutting and welding. Same thing for the transfer ducts too. But to make the engine head and cylinder deck, I used the same method that I did earlier to make 2 of these discs. One of them I bored out to make the cylinder deck, while the other one, I welded a small piece to the top so that I could bore it out to make a hole for the spark plug. But as you can see, the heat from the welding process has caused the head to warp a little bit. Which isn't a big deal, I just did a light facing cut with the lathe, and now it's flat again. Alright, now that all the components are finished, I then welded the whole thing together. And after I was done welding, now I just need to bore out the cylinder. But there's already a problem. When I have the boring bar stuck out far enough to pass through the whole cylinder, it chatters really badly. It's like when you put a ruler to the edge of a desk. The more it sticks out, the more it'll vibrate. And I could try cutting halfway on either side, because then the boring bar only has to stick out half as far. But the problem with this method is that oftentimes, the second cut won't be perfectly aligned with the first one, which results in it leaving a bit of a lip around the middle. But then I had a better idea. I turned a length of square tubing into this huge boring bar, which should be practically impossible to bend.
It might benefit from a bit of a sharper insert, but beyond that, yeah, that is not bad.
Based on the measurements that I gathered from this old engine I had, I did some math and determined that for a piston that's 43.95 millimeters in diameter, I then would need a bore size of 44.05 millimeters, which makes sense to me. Once the bore was finished, I gave it a good hone, then finally drilled some holes. And now it's done. Now all that's left to do is to make the crankshaft. Once these two bars were turned down to size, I then welded a piece of steel to the end of the shaft, then slowly turned it down to the right size. And after welding it all together, I then turned down some pieces of scrap metal I had to form the connecting rod. And after making all the parts that I forgot about, then was finally the time to put the whole thing together. And that is exactly what I wanted to hear. With the engine seemingly producing strong primary compression and transferring that gas into the cylinder, all that was left to do was install the rest of the hardware. And after that, the engine is completely finished. Of course, because this is a two-stroke after all, I mixed up an oil-fuel blend using a ratio of 40:1, which should keep things lubricated. And after confirming that the fuel is making its way to the cylinder,
Yeah, that piston is very wet.
it's finally time to start testing.
No way. It's actually working.
Or so I thought. While the engine runs, in the loosest definition of the word, it would run only until all the starter fluid burned off. And I can tell that something isn't right, because when you look at the slow-mo footage, it seems to misfire every other power stroke, which I think technically makes this the world's worst four-stroke.
Okay.
I tried everything to get this thing to run. I tried playing with the ignition timing, turning the fuel screw, and I even tried using a heavier flywheel as well. But just before I could figure out what was wrong, I broke it.
I'm gonna go to bed. Alright, I'm back. Oh, wow.
I guess there wasn't enough interference between the connecting rod and the bearing, which is annoying because now I have to take the entire engine apart just to fix it. But while I was putting the engine back together, I got to thinking that maybe the reason the engine doesn't want to idle is because of a complete lack of an exhaust. As when the exhaust gas is rushing out and the fresh charge is flowing in, if there's nothing to provide at least a bit of back pressure, a lot of the charge mixture will just get blown out the exhaust. And I think that might explain why the engine keeps misfiring. So, I decided to do a bit more research on the matter, and honestly, I have no idea. Half the people I've found say that it does need back pressure, meanwhile the other half say the exact opposite. I don't know, man, I'm just the guy who throws rocks. But you know what, I guess it couldn't hurt to try. So, I made this. This exhaust has a bolt at the end of the pipe, and by turning the bolt in or out, you can adjust how much back pressure it has. So I put it onto the engine, and once all the RTV was dry, I set it all up for another test. First, I tried it with the screw backed all the way out, for the least amount of back pressure, which didn't seem to work. So I tried it again, but this time with the maximum amount of back pressure, which didn't work either. And what's worse is that stupid bearing fell out again, which led me to spend a whole other day fixing and resealing the engine once again. Alright, so if the exhaust isn't the problem, then it must be the carburetor. A lot of you guys had commented saying that the carburetor looked to be way too big. And I think you're right. Even though it was labeled as being for a 50cc, the throat is still pretty wide, so I don't think there's enough airspeed through the carburetor for it to be taking in enough fuel. So then,
Hello!
I bought another one. This new one has a much smaller 13mm throat, instead of the 19mm throat on the other one. So now, it should be the right size for my engine. At first, it didn't seem to make much of a difference. But when I rested a torch up against the intake, the engine started to sputter along. So I think the engine is just running too lean. And to fix that, I need to adjust the height of this needle on the bottom of the slide. This needle acts like a valve which regulates how much fuel can get through the jet. And this C-clip here is what sets the height. So by moving the C-clip down to a lower groove, it will hold the needle higher up, which will let more fuel through and enrichen the mixture. And now, the engine runs. Except it kind of runs like crap. And after poking around a little more, I can see why.
Bruh. It works.
But even with a brand new battery, there is still something very wrong.
Yeah, that's got nothing. Alright, moment of truth.
Oh, that is really bad.
Okay, look. So I may have blown the engine up. And honestly, I really should have seen this coming. You see, while starter fluid is great at, well, starting things, it's also, very unfortunately, a great solvent. Meaning this entire time, I've been running the engine completely dry. But after seeing just how close it came to finally running, I think that I can work something out. I'm rebuilding the engine once again. And in a last-ditch effort, I put a bit of oil inside the crankcase. After spending almost 2 months of designing, building, and trialing, if I can't get this thing to work, then all of that will be for nothing. It came right to life. And judging by the slow-mo footage, this time it's running so much better. In fact, it runs so well that it has completely smoked out my garage.
I don't know if you're able to see it. There's like a noticeable haze just dumping from my garage.
And because I don't feel like dying in 6 years, I brought everything outside to test it some more.
Absolutely smoked out the garden.
So it runs and it idles pretty happily. But after I let it cool down for a minute, I want to see how it handles wide open throttle. Alright, now this time with the coil tape down.
Just we lost the key.
Wait, is that it? No way.
And since the engine isn't smoking as bad anymore, I brought it back inside to try it once again.
Oh my god. Yeah, that was oddly familiar.
I think I've proven my point. This thing runs, and it runs far better than anything I have ever made. Of course, it isn't perfect. It has no way of keeping cool, the flywheel won't stay on, and if I want to maximize its power output, I'll need a real exhaust. But if you want to see me make more things like this, then subscribe, and I'll do that.